lecture, now we are going to discuss about some of the important terms related to the Nyquist plot. So before going to the discussion of stability criteria of Nyquist plot, we are going to look at some of the important terms related to this plot. Right. So what is meant by encircled? So if a point lies inside the closed path, we can say that point is encircled. So whatever be that closed path is. So if a point lies inside a closed path, it means that got encircled. Right. So here if you observe, in the first case I have taken one clockwise path, closed path. That means with a clockwise direction. So here the number of encirclements are n equals to -1. Okay, our convention is that the clockwise encirclements are negative and anti-clockwise encirclements are positive. So in the second one, if you observe, that is anti-clockwise, then I have taken it as +1. What is that 1 is indicating? That means how many closed paths are there surrounded by a particular point. So right, then coming to the third diagram, there if a point lies uh, there in the outer circle, like between outer and inner circle, for that point the number of encirclements will be +1, and that too in anti-clockwise, right? Okay, then coming to the point inside the inner circle, the number of encirclements will be n equals to +1 -1, both are getting added. That means one clockwise encirclement is there, one anti-clockwise encirclement is there. So by adding them, it is the net will be 0. That's what I represented there, right? So that is very important. Okay, and coming to the fourth example, there again, if you take a point as I have shown there, for the point there, n will be +2. That means there are both, the point is encircled by two anti-clockwise paths. Okay, but for a point there, as I have shown, one more point is there, that is below 1, the number of encirclements n is equals to +1. That means if you observe, that is having only one anti-clockwise encirclement, right? Okay, so you just observe them, you will get to know. Then for a typical Nyquist plot, how to identify these things? Like these encirclements are very important, because for deciding the stability you need to know this in case of Nyquist plot, right? So here I have shown as an example a Nyquist plot for some general function. So in this case, like if you see with the arrow symbols, I have indicated the 4 points and the number of encirclements for that particular point, right? So if you observe the top one, for the top point it will be n equals to -1. That means it is encircled only once in clockwise. And for the second one, n equals to -2. So if you observe, the outer one is there anyways, and again it got encircled by one more clockwise path, so it will be n equals to -2. Then for this like third one from the top, the number of encirclements are 0, because the outer one is clockwise and the inner one is anti-clockwise, so the net is 0. Then again for the bottom one, n equals to -2 again, because again it is inner encirclement is clockwise and overall outer encirclement is also clockwise, right? You just observe it, right? Thank you. It is contour. What is meant by Nyquist path contour? So it is the one which encloses the entire right side of S plane. except poles on j omega axis. Okay, so this is the general. From using this contour only you are going to draw the Nyquist plot for a certain given system. That's we will see. Okay, how we are going to get the Nyquist plot with this contour. Right. So the other basics before proceeding for drawing Nyquist plot and before going to the stability criteria, important point is that the characteristic equation. Like what is characteristic equation? We all know that is the denominator of the closed loop transfer function, that is in general 1 plus g of s into h of s. Right. Then their poles of f of s, that is the characteristic equation poles are nothing but poles of g of s h of s. Yes, right. Are you getting or not? Like if you expand 1 plus g of s h of s, the poles, that means the denominator roots are same for both f of s, that is for 1 plus g of s into h of s, also for g of s into h of s, because the one, like what is the difference between 1 plus g of s h of s and g of s h of s? Just a constant term 1. Right, so it will not affect the poles of both of them. Both the poles are same. And what about zeros of f of s? The zeros of f of s, that is the characteristic equation, are poles of closed loop system. Right. Yes, right. The zeros, I'm talking about the numerator of f of s. They are nothing but the poles of closed loop system, because the characteristic equation f of s is in the denominator of the closed loop system. Right. So the zeros of characteristic equation will be poles of closed loop system. Understand? You try to listen one more time. Right.